Welcome, everyone, to another episode of 26.1 Podcast. Today we have Gert, a former colleague of mine from Deloitte, who's going to speak to us about his interest in machine learning and AI and all the great data science that he's worked on in the past and in the future. Welcome, Gert.
Hey guys.
Welcome. Thank you for joining us.
Welcome. Thanks for having me.
I love astronomy. Maybe start out with your transition from very serious academic astronomy to your current career.
I can quickly talk about that. As a lot of data scientists in general, my background is in academia. So I studied astrophysics, first bachelor, then master's, and then a PhD. That was kind of a mix between astronomy and having AI applied to solve astrophysics problems, which is basically also the place where I first got really introduced to some AI algorithms. Because in pure astrophysics, like education, you don't really get machine learning. You get statistics and you get math, but that's about it. You don't get any of the cool machine learning stuff. So yeah, it was definitely I remember I worked a lot with evolutionary algorithms, and I remember the first time I implemented it, my mind was blown, just because of the fact that the basics of the algorithm are pretty simple. It's basically the translation of survival of the fittest into an algorithm, and then you just let it train, and it's pretty crazy to see how simple rules can lead to very intelligent looking behavior. So I use the evolutionary algorithms to kind of recreate an image of a galaxy. So if you take a telescope, for example, and you take a picture of a galaxy, intrinsically that galaxy is three-dimensional, right? So you have your stars, they're distributed in a certain way. You have your dust that's distributed in a certain way. But the problem is, if you take a picture, you make it a 2D projection of an object that's intrinsically three-dimensional. So the question becomes how do I get that information back out? Normally what we do in real life is you just take a different angle. If you want to deconstruct a chair, you basically take it from different angles, and just having the different angles allows you to reconstruct it in 3D. But because these galaxies are so far away, you can't really do that. Your one angle is basically the only angle you will ever see in your lifetime. So you need to come up with a different way of the projection. And basically what I did there was solve the inverse problem. I first calculate how a certain 3D distribution would project into 2D. And then I created an AI that basically looks for the three-dimensional model that gives the best representation in 2D.
And how do you know? How do you know it's correct? How do you? I mean, something like that. It sounds like you only have one perspective, and you're trying to simulate something there. Is there any measure of what's correct, or you have an astronomer look at it? Or
there is ways that you can know that you're more or less correct. So, and the first thing that we noticed was, if we only look at one wavelength, so for example, suppose I'm only going to look at green light or blue light, then you have a sort of infinite amount of models that would project into the same thing, right? You could imagine a very elongated galaxy or a very short but dense galaxy could still project in pretty much the same image. But that is if you look in one particular wavelength. If you go and you increase the amount of wavelengths that you look at, so you, for example, include blue light, you include red light, UV, infrared. If you include more and more wavelengths, you can kind of create a sort of three-dimensional data cube. And instead of having a third dimension that you see, you actually have the third dimension because you increase your wavelength amount. So, and the reason why that gives you different information is blue light, for example, is hindered quite a bit more by dust. So if you have dust particles, blue light tends to be absorbed faster because it's a shorter wavelength. Red light, infrared light allows you to pass these particles way more easily. So if you look at infrared, you kind of get a more transparent view of your galaxy. If you look in blue light, you're more likely to see the stars that are closest to you. So if you kind of scan from blue to green to red to infrared, you kind of scan through your galaxy in the way that you see it. And how do we know that it's correct? We basically then put that model into like other simulations, and we can kind of predict what we would see in different wavelengths. And if that kind of matches up, that gives us a pretty accurate idea on we're getting pretty close or not.
How much data were you using for modeling? It sounds like the universe compared to the business problems you solve now.
Oh, it depends on where, in what stage you are. If you really want to look at, for example, is this model doing correct, then you're not looking at thousands of galaxies, because that analysis like takes you quite a while. However, running the model, then once you know, like, hey, this model is validated and it works, you can run it on thousands, hundreds of thousands of images. So it's doable in that account. I think the problem in astronomy is usually the quality of data. And I know, like, okay, data quality, and you get messy data in business, you get messy data everywhere. But I would argue that in astronomy, it's even worse, just because of these instruments are very specific. You don't really always understand like how the data was collected, how certain errors could be removed. So yeah, it's definitely different from business in that sense, that there's not that huge of a community that you could like tap into. You kind of, you're a bit more on your own in that sense, in like figuring out what is the best way to clean your data. But yeah, it's doable. It's doable.
And you were in that field, and then you went to Deloitte in Belgium,
Yeah.
correct?
So
How does this? Yeah. So how does it? The problems in that case, how do they, manifest themselves? You mentioned the messy data business, and we all of our clients at Deloitte had perfect data, so I know what you're talking about. But you know, walk us through that. How do you apply some of this machine learning to the problem cases that you had in Belgium, and then when you were on my team here in the U.S.? How do you go from there? And a lot of people are in this space. A lot of listeners are probably from academia too. How did you handle the transition yourself?
So I think it was probably my most heard phrase my first year when I worked for Deloitte in Belgium. It's like, what does an astronomer do at Deloitte? Like most people couldn't figure it out. But once you start talking indeed about the problems, it's not that you have a huge range of very different problems in machine learning. Okay, you have different data sets, and there's very nuances and intrigue like qualities for every specific problem. But in the end, it's kind of like, hey, you have supervised problems, you have unsupervised problems, and these are kind of your algorithms that you work with. And for example, like, what are like few of the first things that you see when you come to industry is indeed missing data, right? And how do I fill in those gaps? Other things are just in general, which I still believe is where you could see a lot of differences between people who have a scientific background and people who kind of picked up machine learning along the way, is reflecting on your data and potential biases. And what I think is great now in our community is how easy it has become to run machine learning models. The danger in that is that you don't always know like how your data is collected, and not everyone like reflects long enough on where does data come from. Did I collect this in the right way? Can I actually use this to solve my problem? Does this data contain enough information to solve my problem? And that's where you can, like, the scientific method definitely helps you in dissecting that problem and getting to like a solution based on, like, yeah, the scientific theory. Like, you make a hypothesis, you test it, can it actually predict on something that you would like to test? So that's definitely something that is valuable today, and it was like from the moment I started working for Deloitte.
A question for both of you: does p-value ever come up in discussions with your clients?
For me, it definitely does. I tend to be careful with introducing them to metrics, though. I usually try to translate immediately like what that means, rather than just like give them the, like, hey, here's the p-value, because they don't necessarily, like, yeah, first of all, it's dangerous, like, giving too much weight to your p-value. It shouldn't be the only metric that you tell them or that you use to kind of say, like, hey, this makes sense or it doesn't. So I usually try to immediately give the translation with that. Like, hey, here's the p-value, and this is what that means. Also depends on your audience, but I guess that's in general. Like, do you have like data scientists from the client side that are there? Then you could be a bit more technical. So yeah, for me, definitely I mention it, but kind of depends on the audience.
Yeah, I always try to translate it, even in the data science, and Gert knows this. I always try to convert problems into metrics that marry well with the problem, the use case. And I always try to classify even a regression problem into, high, medium, low, or t-shirt sizes, or some analogy to make it measurable and tie it back to some incremental business value. And that's hard. And it brings up a good other question. So, Gert, so when you are solving problems, either data science problems, is it mostly other data scientists that you're working with, or are you working with a business audience? And I know the engagement model at Deloitte, but is it, speak a little bit how you do translate, scientific findings to people in your
You mean
field?
in astronomy, or you mean in Deloitte, or
Yeah, in
um,
business. So in Deloitte,
so
yeah,
how I
like
do
consult.
that exactly, you mean?
Yeah, so give us an example, like for our listeners. What's an example of a case where you have, you know, um, successfully learned how to translate AI and machine learning results into,
So
business findings,
this
or
is, it's
some
just
some.
sort of a, yeah, you could say it's a fictional use case, but I use it a lot to show the power um, of AI and how you translate it. But it could be a real use case, so that's why I use it a lot. So suppose you go to like a company and you're asked to predict when the machine would fail, and they give you like some historic data, like, hey, here is our sensors from like the past few years. Come up with a model that predicts when this is about to fail. Um, First of all, a lot of people want to know the accuracy, right? Because, like, okay, how accurate is the model? Well, if your machine is only failing like once or twice a year, even if you predict it never fails, you get an accuracy of 99.9%. So that's the first like use case that I tell them, like, look, it's not because your accuracy is high that you're actually creating value. Second is also, it's a great example because suppose you then make a model. And I said it, like, it's not a real use case, but it could have been. And there's definitely analogies that I could make to actual projects that I have. Suppose you make a model and it predicts, hey, given these sensor values, given what I see, I predict the machine is going to break down in an hour from now. Okay, great. You implement that, you put that in production. 1 hour before machine fails, an alarm goes off. Like, hey, this is wrong. These sensor values tell us like our machine is going to fail. But what do you do with that, right? So like, imagine like you're next to that machine and an alarm goes out and it tells you like, hey, your machine is about to fail. okay, but now what? And it shows you that there's um, a difference between prediction and explanation. And prediction is not a valid substitute for explanation. Um, at that point, you might really even consider like, what is my prediction worth if I can't really like give an action plan to it, right? Like, what do I specifically do now with my machine? Do I turn it off? Where do I need to check like where it could be wrong or why it is failing? So it's I like to use that use case for a lot of these things because it shows you that if you would present this use case to a lot of data scientists, a lot of them would come up with very different ways. But the problem really there is like, what am I solving? I'm not necessarily solving the prediction of when it fails, but like, what do my people really need to do with that information? So as I said, not a real use case, but I think it shows like a lot of problems that you have with real life cases.
I would love that, and it's actually really relevant to a problem I've been working on too lately. Um, Precautionary tale. So you're in the space of AI, and you live in a world surrounded by AI. And are you still living in New York City? Are you?
I am. I
Okay.
am. Yep.
So you're right in the heat of it in many regards.
I
Yeah.
am.
So
Yeah.
which is great, and you see all the problems frontline too. What is the precautionary tale about AI? Can it go wrong? Can it? Is there any ethical or other issues that come into play in your mind? Are you scared of it at all?
I'm definitely not scared of it. I think as anything, you need to be careful, like how it's implemented, who implements it, and that's why I have like, I have a my feeling is like two-sided on seeing like how easy it becomes to run machine learning models, and I've often made the comparison with, suppose we come up with a tool like, hey, we can now do brain surgery really easily. Like we can just open up a skull and we can like cut out some stuff. It's not because it's easy to do that everyone should do it. And I have a little bit of that feeling with a lot of the AI stuff. Is like, it shouldn't allow us to take shortcuts, right? We shouldn't skip the basic steps and like first learn your statistics, first learn the basics of, for example, a scientific method. Like, what am I looking for? What is the data that I'm looking at? And not just skip from, here's your data set, it's all clean. How do I run a machine learning model? Great. I mean, it's, as said, it's great, but I think we should be careful with. It's not because it's easy that it should be, or that it should be done by everyone. Um, that is one thing. And then the second thing, like overall for AI, am I scared, or am I? It's probably. I always made a comparison. Like, if you look at the past industrial revolutions, um, people were scared of like, oh, for example, the first one is, oh, is this going to steal our jobs, or like, is this going to like, suppose you were a cloth weaver at that point, right? And you see like all of these mechanized steam engines that started making textiles. You could have imagined like, oh, hey, there's no more room for people who make clothes. But what we see is that all of these industrial revolutions actually created more jobs than less. And I do believe that is something that we can expect now as well. Like, it will make a shift in jobs. And if you think about particular jobs, then you could think like, hey, these going to be replaced. But I honestly see it more like some will be augmented by AI. And overall, I think, and I don't know exactly the source, but I think I read like last week, and this could have been like a pre-COVID analysis, but still, yeah, holds ground, I guess. That by 2 years from now, AI will be a bigger job creator than it will actually replace jobs. And I do honestly think that is reality.
That is hopeful.
Mm-hmm. Mm-hmm. Absolutely.
So, do we dare veer into UBI?
On what sense?
Uh, there are some folks who are bullish on AI who also feel like it should be concurrent with seriously exploring UBI. I think Kai-Fu Lee is one of those proponents.
Yeah, it's a, I mean, it's the problem with like something like that is like you need to be careful with how you test it, how you take results from that. Like, yeah, there's like, how do you properly test whether this makes sense? I think in Finland or something, they did a lot of studies around universal basic income, but yeah, like, can we translate like how the Finnish community would deal with that to any place in the world? So it's an interesting discussion, and I'm definitely not the right person to even like think about.
Well, what we could ask you about is French fries.
Oh.
What are your thoughts on French fries?
Well, actually, they're called. Do you know why they're called French fries? Actually,
I have no clue.
So they're not French; they're Belgium. But I'm Belgium, so I probably slightly biased on that part. But they're called French because it comes from the word Frenching, and Frenching means like cutting vegetables in like long.
Uh,
Yeah, and they were called French fries. But at least that's what they told me, is that Americans came to yeah, I think it was the First World War, and they heard French fries, and they assumed it was French. So it became French fries.
and you guys have a surplus there too. I mean, I don't know about universal incomes, but if the currency is French fries, they're telling you to eat more of them right now.
It is
Right?
true. Like, yeah, we have a surplus of potatoes. So they advised the Belgian population to eat fries twice a week. And the funny thing with that is like, um, I don't know why they specifically said fries. Like, I mean, there's way more you could do with potatoes than just fries, but that seemed out of question in Belgium. Like, no, it's fries. Like,
Well,
It's got to be.
speaking about
It's gotta be
Belgium,
fried.
have you ever gotten to apply AI to beer?
I actually did. Like, I had a like a web scraping tutorial where you could like scrape data from for Belgian beers, and then use Bokeh to kind of make a visualization on the alcohol percentage per type. Which was it was a really cool tutorial in my opinion. But the problem is like one of the websites that I used like changed format, and it's gone now basically. So I still have the results, but yeah, I liked it because it kind of was a tutorial, and the first person to recreate one of the bokeh visualizations got a basket of Belgian beers. Um,
Uh,
yeah,
this is
exactly,
motivation.
exactly.
Motivation.
And the fun part was, like, if you plotted the alcohol percentages, the weird thing was that alcohol-free beer was not always alcohol-free, which I thought, like,
Oh yeah, that's funny. Well, we did have Peter Wong on here, and I believe he's the creator of Bouquet, so he'd be happy to hear that. And I think he enjoys
I'll send him
gamification
the
as well.
visualizations, and he can tell me if he likes them, and he can if he can recreate them, I'll send him some beer as well.
Yeah.
For sure, and I know I know John Hunter had the Matplotlib competition too, and it'd be interesting to see some in the Bouquet world too. I always liked that visualization library. Well, so how do you people find you? Do you want to leave? Do you want to have a leave behind or something? Kind of. You know, if is there a way to find you on LinkedIn
Yeah,
or
definitely
anywhere?
LinkedIn.
If anybody,
Definitely the best place to connect with me for sure. Apart from that, I was working on a website, but like I still need to work on it a little bit more. That's a good thing about the quarantine, is like you can get like a lot more time to work on those ideas that you had in your head for a while. Because I was supposed to make a website where I was going to explain astronomy and AI related things for everyone, like in very short Instagram style stories, kind of within less than a minute, basically explain AI and astronomy concepts. And I've been doing that before.
No, that'd be great. I was thinking of what is her name, Julia. I forget her name. She's big in the Python community. She does these little cartoons and she tweets them out about Unix and Python and stuff. It's been really successful. That'd be great to have that for astronomy. I think a lot of people would educate.
I know whom you're speaking of. She's from the Montreal community.
Yeah. Well, probably I could add the reference at some point. Well, it was great having you on. Stick around for a second, but thank you for being on. It was really fun. It was really exciting.
This goes by real fast, even like 26.1. Now that I finally get where it comes from.
Thank you very much, Gert. Great meeting you.